Okay, so in today's video, I'm going to talk about a method to find Pythagorean triplets, which are basically numbers a squared plus b squared is equal to c squared. For example, 3 squared plus 4 squared is equal to 5 squared, so that is a Pythagorean triplet. So the idea is basically if I have a rational number squared plus another rational number squared that is equal to 1, for instance, a over b squared plus c over d squared is equal to 1, then all you have to do is multiply both sides by bd squared, and what you will get is you will get AD squared plus BC squared is equal to BD squared. And this will be a Pythagorean triplet, of course, because A, B, C, and D are all whole numbers. So the idea is, how can we find rational numbers that when you square them and add them, you get 1? Well, this is just equivalent to them being on the unit circle. So what we need to do is we need to find rational points on the unit circle. So how do we go around doing this? So all you have to do is you start with let's say just a very trivial rational point on the unit circle, 0, 1. Okay? This is very trivially on the unit circle. It's not a very interesting, exciting point. But what you do is you draw any rational line you want through that. By a rational line, I mean it has a rational slope, okay? So for example, you could choose the line that goes through 0, 1 and has a slope of 47/19. That's valid. That works. Okay? And this is going to give you an equation to solve for what is the other point where it intersects the circle. Right? Because you have the circle, you have the lines going through your point on the circle. The question is, what is the other point that is going to pass through on the circle? So to do this, you can plug in the equation of the line, which is going to be a rational equation since you're going through a rational point with rational coefficients. And you plug it into the equation for your circle, x squared plus y squared is 1. And what you get is a quadratic equation involving x. Okay? And when you expand it, it's easy to see that there will be a 0 for the constant coefficient of your quadratic equation. And also, the coefficients are all rational numbers. So, because we already have the solution where x is equal to 0, that was the point we started with 0, 1, we assume that x is not 0, and we can just divide by x and easily manipulate this equation a little bit and solve it. And because it's a rational equation, all the coefficients are rational, it is very easy to see that x is going to end up being a rational number. Now, all we need to do is realize that because x is a rational number and this is on a rational line, because we define this point to be the intersection of the rational line with the circle, the y-coordinate is also going to be a rational number, which we can calculate very easily like this. And so now we have rational numbers x and y on the unit circle, which by what we mentioned earlier, you can transform like this into a solution to a squared plus b squared is equal to c squared, which we have done here. And finally, these negatives do not matter because you're squaring them, so I'm just going to switch them to positives to make it look nicer, although it does not really matter. And you can check, you cannot simplify this any further. There's no common divisors you can divide out. So this is it. We're done. So this is our solution. You can do this with basically any rational line to get tons and tons of non-trivial Pythagorean triplets. So thank you for watching my video. Bye.